So, hello everyone, and welcome to my talk on data transformation and exploratory analysis. I'd like to start off here by asking you guys a few questions. So first, how many of you consider yourselves data scientists? Okay. How many of you spend a lot of time exploring data? All right, great. And the third question, how many of you have a formal process or framework that you use for doing data exploration? Okay, excellent. You've all come to the right place. So what I'd like to do in this talk is tell you a little bit about the process that I use for exploratory data analysis in my day-to-day work. And for the few of you that had a process of your own, my hope is that you see some similarities between my approach and yours, and that you take away a couple of ideas of things that you can incorporate into your own process. And for those of you that don't already have a process of your own, what I hope that you take away from this talk is an intuitive, repeatable framework for analyzing, visualizing, and finding insights in your data. But before I jump into that, I'd like to tell you a little bit about myself. So that's me. My name's Tony Ojeda. I've been in the analytics space and more recently in the data science space for a little over a decade now. I'm the founder of District Data Labs, which is a data science research lab and open source collaborative based in Washington, DC. And I got into data science from kind of a business analytics and finance background, which is where I acquired my analytical and quantitative skills. And then I taught myself how to program over the years in both R and Python. And so in the years that I've been in this field, I've worked with my fair share of analysts, data scientists, as well as students learning data science. And I've noticed that, particularly during the data exploration phase of their work, I often see them grasping at straws when it comes to their approach to finding insights in the data. And so I wanted to put this presentation together to help create a more structured path for people so that they could follow it and view insight discovery as a problem, break that problem down into manageable components, and then work toward a solution. And so in this talk, we're going to look at an example of a real data set. I'm going to introduce you to the framework that I use, and then we're going to walk through the concepts in the framework and use them on the example data set. But before I do that and jump into the framework, I'd like to provide a little bit more context, talk a little bit about what data is and how I think about it. So data is basically just encoded information, and information is everywhere. Everything that you know, everything that you can think of, everything that you encounter every moment of every day has the potential to be captured, encoded, and therefore turned into data. And this makes our world a very complex web of it. And so we can think of each data set that we encounter in our work as just a slice of this complexity that someone has put together to communicate something about the world to either a human or a machine. And so now as humans, we have this built-in ability to deal with this complexity all around us and all this information that we're constantly receiving. And the way that we do this is by organizing things, right? We put things in order, we group things into categories, we create hierarchical classifications, taxonomies, we tag things now, all that stuff. And these things help provide order and structure to the way that we view the world. And they allow us to be able to take a look at something, recognize the similarities it has to a group of other things, and then identify its properties it has so that we can be able to make decisions about it. And so the fact that this ability to create kind of order out of complexity is built into us is great. And we use it all the time, really, without ever really thinking about it. And unfortunately, that also includes when we're analyzing data. And so I wanted to put together a data exploration framework that took advantage of this ability in us and that would help us make better use of it in our workflows. And this is what I came up with. So the framework is basically broken down into two phases. There's the prep phase on top, and then you've got the explore phase. And throughout the presentation, we're going to walk through each of the steps here. And I will point out that you can technically do the explore phase without the prep phase, but it's really the prep phase that's going to allow you to do the exploration well. And so I highly recommend taking the time to kind of go through the entire thing. All right, so the data set that I'm going to be applying this framework to today is the Environmental Protection Agency's Vehicle Fuel Economy data set. And I've included the URL there, so anybody that wants to download it can download it. And this is what the data set looks like after some light cleanup. All right, and so jumping right into the framework here, the first step in the prep phase was to identify a few different things about our data set. So let's go ahead and do that. The first thing that we're going to identify is the types of information that are contained in our data. And so just from taking a look at this, there's a few kind of obvious types of information that really jump right out at us. We've got vehicle attribute information in there. We've got vehicle manufacturer information. We've got engine information, fuel information, all these things, right? There's also some additional kind of maybe not so obvious types of information that are in our data set. So since we've got the year in there that each vehicle was made, we can take a look at changes in the data over time. In addition to that, there's also relationship information in our data set, both in terms of the relationships between fields and also between entities. And because we have both time and relationship information, we can acquire information about how those relationships change over time as well. All right, so the next step is to identify the actual entities that are in our data. And so what exactly do I mean when I say entities? So when I refer to an entity, I'm talking about the individual analyzable units that are in a data set. In order to conduct the analysis, the entities must be distinguishable from one another, right? A human or a computer needs to be able to look at them and say, this is one, this is another, etc. And finally, entities usually have a hierarchical structure where they're usually able to be aggregated into the system or the higher level entity that they belong to. And so now that we've defined this, let's take a look at the entities in our data set. So here, we're starting off at level 1, which is the most granular that we have, and that's the year and the specific model of vehicle. And now from there, we can aggregate that up and look at the year and the model type, which is a little less granular. And from there, we have a few different directions that we can head in. We've got the year and the vehicle class, the year and the make, or we can just strip the year away and keep the model type. And then finally, at level 4, we can aggregate even further to just the vehicle classes, the years, or the makes. To drive that home and clarify it a little bit further, here's an actual example from the data set. So down at the bottom level, which is the year and the specific model, you have a 2016 Ford Mustang with a 2.3 liter V4 engine, automatic transmission, and rear wheel drive. At level 2, we can roll things up and take a look at just all 2016 Ford Mustangs as one entity that we're analyzing. And then at level 3, you can do the same thing kind of with all 2016 subcompact cars, all 2016 Fords, or just all Ford Mustangs regardless of the year that they were made. And then it's kind of up the hierarchy from there. And again, so doing this is important, and it'll help you think about all the different things that you can do with your data and all the different ways that you can look at it later on. And I see a lot of people that are new to data science that don't do this, right? They don't think like this, and then they miss things in the data that they should be catching. So I hope that this helps to make that a little bit clearer. All right, so the next step in the prep phase is to review some of the transformation and visualization methods so that they're fresh in our heads here. And so first up are the transformation methods. So let's take a look at some of my favorite ways to transform data here. So the first one I've listed is filtering, which is basically making the data set smaller by either looking at less rows, less columns, or both. The next one I've listed is aggregation and disaggregation, and this is basically where you're changing the levels at which you're analyzing the data, so you're getting either less or more granular. Then we have pivoting, which is where you aggregate by more than one variable along two axes, so along the rows and along the columns as well. And then the last one I have on here is graph transformations, which is where you link the entities that you're analyzing by the things that they have in common, and then examine the connections between the entities and how they're related to each other. And so by transforming the data, you're ultimately altering the structure of it, which lets you take a look at it from a bunch of different perspectives. And just like looking at anything else from several different perspectives, you're going to learn something new about it from every way that you look at it. And the awesome thing about that is that the number of ways that we can transform the data is only limited, really, by our creativity and our imagination. And so this, for me, is one of the most exciting things about working with data, right? All the different things that you can do to it and all the creative ways that you can transform it. In addition to transforming the data, I also like to go a step further and visualize it. Sometimes transformations that you perform can be kind of difficult to interpret visually, and I find that plotting really allows you to bring the human visual cortex into your analytical process and usually makes the insights jump right out at you. And so transformation and visualization really go hand in hand. Since there's a multitude of ways to transform the data, there's also a bunch of ways that you can visualize it. I personally like to keep things fairly easy, and so here are a few of the visualizations that I use most often. And if you don't know what a few of these are, there's tons of pictures. All right, so the last step in the prep phase is a little bit more involved, and that's to create additional categories, additional categorical fields that are going to make our data easier to transform and explore later on. And we're going to do this in 3 different ways. The first way is identifying opportunities to create higher level categories out of the categorical variables that we currently have. And so imagine here aggregating by transmission, which has 44 unique categories in our data set, and trying to look at that and analyze that. It's going to be tough, and you're going to have to work really hard to find any kind of insights there. But if we take a look at the different categories and find things that some of them have in common, then we can make it a little bit easier on ourselves. And so in this case, the thing that all 44 values had in common is that they fall into one of 2 categories, right? Either automatic transmission or a manual transmission. And the same thing with the vehicle class field in our data set. We start off with 34 different categorical values, but I was able to distill those down into 8 categories, which is a lot easier to look at. And so keep in mind that when you're doing this, you're not overwriting the original categories. What you're doing is you're creating another categorical field that's allowing you to view the information at a higher level. And so if you need to drill down to the more granular categories, you can always do that. But at least now that you've done this, we have a choice. The next way that we can create additional categories for ourselves is by binning our continuous variables. So breaking them up into different categories based on how high or how low they are. And there's multiple ways that you can do this, but I like to use quintiles because it gives me one middle category, and then 2 categories outside of that which are moderately higher and lower, and then 2 extreme categories at the ends. And I just find that that's a very kind of intuitive way to take a look at things and to split things up. And so here I've identified 4 fields in our data that we could do this with, and I've created quintiles for each one. And then the final thing that we're going to do in this phase is cluster to create categories out of the different clusters that the algorithm finds. And so there's a few reasons that I like to use clustering for creating categories specifically. So first, it takes multiple fields into consideration together, whereas the other categorization methods that we just looked at only consider one field at a time. It also creates new categories for you automatically, which saves time versus you having to comb through the data trying to find patterns that then you can form categories on. This will automatically group all the similar items together for you. And the third reason I like clustering is because it sometimes groups things in ways that you as a human may not have thought of, right? And I'm generally a big fan of humans and machines working together. But the question with clustering is always, well, how many clusters, right? And the answer is usually it depends. There's no real right answer for this. And so that being said, for this purpose, I usually like to keep it to under 10 because otherwise it becomes kind of too many categories for you to take a look at and intuitively distinguish between. And when you're clustering to create meaningful categories, it's key that you're able to distinguish one from the other, just like the entities that we discussed earlier. And so I usually start out with about 8 or 10 clusters and then work my way down until I find some clear boundaries between the clusters. So you should be able to look at them and visually distinguish one from the others. And so starting out, that's going to look like this, right? So I basically ran the numerical fields in our data through a k-means clustering algorithm and had it group the data into 8 clusters. And so just from looking at this, you can tell that we probably have too many clusters here, because clusters 3, 4, and 6 look a lot alike. Clusters 0 and 1 are also pretty close, and clusters 2 and 5 also look a lot alike as well. And so just judging from the way this looks, I'm willing to bet that we can cut the number of clusters in half and get better boundaries. So let's take a look at that. All right, so here we've reduced the number of clusters down to 4, and now the clusters look a lot better, don't they? So clusters 0 and 1 kind of look like polar opposites of each other. Cluster 2 looks like it's pretty well balanced all the way across the board, and cluster 3 looks like it's kind of halfway between clusters 0 and cluster 2. And so now that we have a good now we have a good number of clusters, right? But it's kind of hard to remember what clusters 0, 1, 2, and 3 mean. And so the next step I like to take is to assign descriptive names to each of the clusters. And so here's, based on the fields that we were using to cluster, I've basically just assigned some descriptive cluster names to each one. And so now that we have these meaningful categories, our data is in really good shape, and that means that we can move on to the explore phase. So in this explore phase, we're going to first look at filtering and aggregation, and then we're going to look at relationships between fields, and then after that, we're going to move on and look to relationships between the entities in our data. We're going to look at these things visually. We're going to look at these things over time, whenever possible, and we're going to use them to discover insights in our data. And so to start out here, I've filtered the data by year, so just for 2016, and I've aggregated it by vehicle type, and here's what kind of the transformation looks like, and then the accompanying bar chart. And so from this, we can see that there's currently significantly more small cars being made than all the other cars, followed by SUVs and then mid-sized cars after that. And so once you've done this once, it's pretty easy to change out the year and get a different historical perspective. And so here's the exact same aggregation for 1985 this time. And so here, SUVs didn't exist yet. Small cars are even more popular, as were pickup trucks as well. And then the next one was special purpose vehicles, which is things like ambulances, ice cream trucks, that kind of thing. And so in addition to being able to change the year here, you can also change out the field that you're grouping on. And so here, we've come back to the current year, and I've plugged in the engine size quintiles that we created earlier in the prep phase. And I can do the same thing with the fuel efficiency categories that we created, or even with the clusters. And this is great, but what if we wanted to take a look at the vehicle manufacturers, right? Let's say we wanted to know how many models each manufacturer makes, or even which manufacturer currently has the most models out there. Well, we can do that as well by just plugging in the make field. And so here we can see that BMW currently has more models on the market than all the other auto manufacturers, and by quite a bit actually. All right, so far we've been looking at the data at a pretty high level, aggregating up by just a single categorical variable at a time. Next we're going to go down a level and take a look at 2 or more variables at a time. And the way that we're going to do that is with pivot tables. And so here I've created a pivot heat map where you have a row for each fuel efficiency category and a column for each engine size category. And you can see how many vehicles fall into each combination of these. And now, just like we did earlier, we can slice this by a different year and easily get a different perspective. So here's what the heat map looks like for 1985. And so with this approach, we're not just limited to 2 variables. We can have multiple variables for any of the axes, and it'll show all the different combinations of values for those variables by whatever other variables we want. And so in this heat map, I've doubled up on the rows. I've got the engine size and the fuel efficiency combinations represented by the rows, and then we've added a third variable, the vehicle category, across the columns on the bottom there. And so now you can see a finer level of detail about what types of cars have what size engines and what level of fuel efficiency. We've added a little bit more complexity and a little bit more granularity to how we're viewing the data here. And so if we wanted to go back to analyzing the different manufacturers, what we can do is take a look at how the number of models they have on the market is distributed across the different vehicle categories. So kind of something like this. And now I've got a better sense of each company's current strategy in terms of the breadth versus the depth of vehicles that they make. So by taking a look at this, we can see that like BMW is making a bunch of small cars, more small cars than any other category, and Porsches also. Ford, Chevy, and Nissan are kind of going for breadth. They make vehicles in almost every category. Jeep and Land Rover are making only SUVs. Ram is only making pickup trucks. There's a few other companies that are only making small cars, and then all the other companies are kind of somewhere in between there. All right, so in addition to looking at these different aggregations and pivots visually at a given point in time, I also find it very useful to take a look at how they've changed over time. And so that's what we're going to do here next. So for example, here are our vehicle categories over time. So we can see from this that small cars have generally dominated across the board. We can also see the introduction and increase in popularity of SUVs starting in about the late 90s. And we can see the gradual decline in popularity of pickup trucks as well. And so now from here, if we wanted to, we could zoom in and filter for a specific manufacturer in order to see how their specific strategy has changed over the years. And so here's the same chart for BMW, their vehicle categories over time. And we can see that they started off making a reasonable number of small cars, and then sometime in the late 90s, they made a decision to start increasing the types of small cars that they make. And we can contrast that with a company like Toyota, for example, who started out making a lot of small cars and then made a decision kind of around the same time to start making less and less of them over the years, instead shifting their focus to SUVs and pickup trucks. All right, so that's the filter and aggregate stage. The next step in the explore phase is examining the relationships between fields in our data. So for looking at the relationships between variables, I like to start off with a scatter matrix. And this kind of gives me a bird's eye view of all the relationships in all the fields in my data set. So from this, we can see that there are some kind of more linear relationships in there. There's also some more exponential ones as well. And this is great, but what's even better is that we can add another dimension of insight to this by overlaying a layer of colors on top of this that represents, for example, the clusters that we created earlier. And so here I've overlaid our clusters. And now we can see not only the relationships, but also where the different cluster boundaries are and how much overlap there is from one cluster to the next. And once we've got this colorful bird's eye view now, we can easily zoom in on anything that looks interesting to us. And so here I've zoomed in on the engine size versus the fuel efficiency fields with the clusters overlaid. And so from this we can see kind of our very small our small, very efficient cluster on the upper left in the purple there, followed by our small, moderately efficient cluster in blue, and then our mid-sized balanced cluster in red, and finally our large, inefficient cluster at the bottom right there in green. And so here I've clustered the engine size against the fuel cost, so more of a linear relationship with the clusters. And here the clusters kind of follow the same progression, but this time from the bottom left to the top right. And again, you can do this for any combination of variables that you had in the scatter matrix. All right, so the third step in our explore phase is examining relationships between entities in our data set. And the way that we're going to do that is through graph analysis. So as I said before, graph analysis is going to allow us to explore the relationships between entities, and these relationships are usually based on attributes that the entities have in common. So the entities we're going to analyze in our example here is the auto manufacturers, and in this case, the attributes that they have in common are going to be vehicles with similar attributes. So we're going to examine how the different manufacturers relate to each other and how those relationships have changed over time. Now, in order to do this, we're going to have to transform our data set yet again from the relational form it's currently in here into graph form. And that's going to look like this. So here we have two different companies as make X and make Y, and then we have an edge weight. And the edge weight tells us how many vehicles with similar attributes the two companies have in common. And so the more vehicles with similar attributes they have in common, the more alike the two companies are going to be, and the stronger their connection is going to be. And so looking at the data in this format, you might say there's not much to it, and you're right. But having it formatted like this lets you create really interesting things like this. And so this is a network visualization showing the relationships of the different manufacturers to each other. And from taking a look at this, we can see, for example, that the companies that make the most types of vehicles across the most number of categories are positioned towards the center of the network. And that's because they're going to have more in common with other companies just as a result of the depth and breadth of their offerings. You can contrast that with other companies that have more specialized offerings, like Ram at the very top there, or Land Rover at the bottom. They only make one type of vehicle, and so they have less connections, and they're going to be positioned towards the edges. So this is great, but taking a look at all this all at once does make it look a little bit cluttered. And so what I usually like to do from here is to filter this down and take a look at an ego graph for a specific node. And so I went ahead and I created an ego graph for Nissan here. And here you can see that they're now at the center of the network. And you can also see all the other companies that they have vehicles in common with and how those are all connected to each other. So a lot easier to see here at this point. Another thing that you can do with graphs is community detection. And so I took our original graph with all the companies in it and all the connections, and I ran it through a community detection algorithm, and it was able to find 4 communities. And so here I basically just color-coded the graph based on the community that each company fell into. And you probably already guessed what's coming up next, and that's taking a look at how the connections have changed over time. And so in this line graph, this shows the number of edges or connections for each company over time. And again, when you have a lot of nodes in your graph, this can tend to look a bit cluttered also. But remember that you can always filter it down for just the specific companies that you're interested in. And that's what I've done here. So I've just chosen a handful of companies, and now we can see kind of more clearly how each of their connections have changed over time and converged in recent years. All right, so we've done a lot to this data set in just a short amount of time and using just a few simple concepts. So let's do a quick review. So here's a picture of the framework as well. So we started off with the prep phase at the top there, and the first thing we did was we identified the types of information and the entities in our data set. Then we moved on to reviewing the different transformation and visualization methods that are available to us. And then we created additional categories in our data, and we did that 3 different ways. We did that through category aggregations, we did that by binning our continuous variables, and we did that by clustering. And then at that point, we were ready to move on to the explore phase. We started off by doing the filter and aggregate step, taking a look at the bar charts and the pivot heat maps. Then we moved on to the relationships between our fields, and then finally we used graph analysis to analyze the relationships between our entities that are in our data. We did all this visually, we did all this over time whenever possible, and what do we end up with at the end of the day? So many insights, right? I mean, just in the short amount of time that we've been taking a look at this data set, look at all the insights that we've discovered from it. About 1 insight per minute on average, which is actually pretty good. So we're not doing too bad here. So, in wrapping up, I'd like to leave you with a few more things to think about in addition to just the framework. I hope that you find the framework useful, but there are a few other important, kind of more understated things that I'd really like to call attention to here at the end. So the first thing is I'd like to encourage you not to take the data that you're given at face value. Right? It's only really a starting point, and I hope that I've demonstrated here that the more effort you put into thinking about the data, prepping the data, transforming the data, and looking at the data from different perspectives, the more valuable insights you're going to find. The second thing I'd like you to consider is whether or not something like this can be automated, or more specifically, which parts of this can be automated and how can we do that. So my personal opinion is that there are definitely some parts of the framework that can be automated, but there are also other parts where it's very important and very valuable to have a human and a human's intuition in the mix there. And that brings me to the last point that I want to stress, and that's the importance of humans and machines working together to discover more insights in the data than either could on their own. And I'm specifically interested in optimizing the balance between which analytical tasks a human is better at and which analytical tasks a computer is better at, and using that to get the best results possible. And if these things that I'm talking about interest and excite you, we have an open source project called Cultivar at District Data Labs that we're starting to build, and we'd love to have your help. So, thank you very much. If you're interested in collaborating, please get in touch. Here's all my contact info. I'm going to be posting the slides and the code also for everything that I did in the presentation on both Twitter and on LinkedIn as well. So please check me out there. All right.